Alright guys, so we're doing circles still today, and we're still working with those secants and the tangents. The only thing today is we're not going to focus on the angles as much as we're going to focus on the actual segments. So there are some more formulas you're going to have to know. So let's go ahead and get started. First we're going to do special segments. Okay, just like when we were doing angles, if you have two chords that intersect inside the circle, there is a certain rule that follows. Now we know if we're looking for the arcs that we add the arcs and divide by 2. But this time we're actually looking for the piece of the segment. So I don't want to know what the chord is, I want to know what a piece of the chord is. So what you would do here is, let's label this. Let's call this A, B, C, D, and then we'll just call this intersection E. Alright, so what we would say is we would start out and we would go AE times EB is equal to CE times ED. So this piece, so this piece times this piece equals this piece times this piece. So they're going to be on the same line as each other. So AE is X times 8 equals 12 times 9. So 8X equals 108. Divide by 8. X is 13.5. And we're going to get lots of practice in class. Okay, the second one is when you have two secants. Okay, so there's kind of a rule, and when you have two secants is you take the outside times the whole side equals the outside times the whole side. So you're going to have 4 pieces. So what we're going to do is we're going to find what those pieces actually are. So for example, this whole piece here would be 8 plus x. So this whole thing is 8 plus x. This whole thing would be 10 plus 24. So 10 plus 24 is really 34. Alright? So the rule is the outside, EH, times the whole side, EI, equals the outside, EF, times the whole side, EG. So we plug in the numbers. So EH is 8. EI is 8 plus x equals EF 10 times EG, which we said was 34. So now we just do the math. 8 times 8 is 64. 8 times x is 8x. So 64 plus 8x equals 10 times 34, 340. So now subtract 64 from both sides. So now I have 8x equals 276. Divide by 8. X is 34.5. So just this piece right here, that itself is 34.5. Alright. The next one is when you have a tangent and a secant. So when you have a tangent and a secant, there is, the rule is the tangent is squared, so you take the tangent and you square it, equal to the outside, since it's a secant, times the whole side. So now you're going to say, let's label these. Let's say ABC for the secant, A, point B, point C, and we'll call this point D. So now this time we're going to go tangent squared, so AD squared equals outside times whole side. And now let's just plug in the numbers where they go. Well, first of all, we need to find out what the whole side is. So this would be x plus, because this segment plus that segment, x plus x is 2x plus 2. So my whole thing is 2x plus 2. So first of all, I have my tangent, which is AD, which is x plus 4. So x plus 4 squared equals the outside x times the whole side, 2x plus 2. So now this really means x plus x plus 4 times x plus 4. And if you'll remember FOIL, x times x is x squared. X times 4 is 4x. Inside, 4x. Last is 16. So I still have to do this side over here, but we're going to go ahead and take care of the tangent. So I've got x squared plus 8x plus 16. Now over here, I've got x times 2x, which is 2x squared, and x times 2, which is 2x. So I'm just going to keep bringing that down because it's pretty much combined. Alright, so now I can start moving everything around. Since it's quadratic, one side has to be equal to 0, so minus x squared on both sides. And they're not all this difficult or this long. And I got to subtract the 8x. And I need to subtract the 16. So I'm just going to move this whole thing over here. So 0 equals 2x squared minus x squared is x squared. 2x minus 8x is minus 6x. And then there's nothing to go with the 16, so we're just going to let it be. Alright, so now I've got to factor this. My little process that I use is my x box. So I take the middle term and I write it in the bottom. Oops, that's just a 6. And then I take the end term and I put it here. And then I'm going to write my factors. 1 times 16, 2 times 8, 4 times 4. Out of these choices, one of them need to be 16 so that I get negative 16. So I'm going to go with the bigger number here since this is negative. So 1 minus 16 is negative 15. 2 minus 8 is negative 6. So these are my factors. X plus 2 and x minus 8. And they equal 0. Now you have to take both pieces and set them equal to 0. So I've got x plus 2 is 0. So that means subtract 2 from both sides. So x is negative 2. Since this is x cannot be negative, so that answer will not work. X minus 8 is 0. Add 8 to both sides. Cancels out here. X is 8. So this is a length, so it has to be positive. So answer is x is 8. Okay, so those are all you have to know for segments, special segments. So now let's look at tangents. Okay, when you have a tangent, okay, first of all, my tangent line is tx. Make sure you put the right symbol over the top. My point of tangent C is just a point. 1 letter is all I need. The point in the interior, well, P is inside and so is point I. And the point on the exterior is X. T is not outside, it's on. Alright, so, first of all, if a line tangent to a circle that is perpendicular to the radius, okay, that is the rule. So if you have this tangent line BA and it's perpendicular to the radius, then that means it makes a right angle. Well, that means I have a right triangle. So I can find this whole side here by doing Pythagorean theorem. So 5 squared plus 12 squared, that's 25 plus 144, which is 169. And then remember, you always take the square root, so you get 13. So this whole thing is 13. But I don't want the whole thing. I just want this piece right here. Well, this radius is 5, so this radius is also 5. So then I subtract 5 from 13 to get the part that's sticking out. So the part that's sticking out is 8. Okay. Another rule is when you have two tangents coming from the same outside point, so this tangent line and this tangent line, then they're just flat out equal to each other. So this piece is equal to this piece. It's kind of like a party hat. So 2x minus 3 is equal to 27. Solve it. So add 3. These are always super easy. 2x equals 30. So x is 15. So this piece is 15. Okay, and then the next theorem is, it's not really a theorem, it's just kind of a fact that we're going to use from the previous theorem. It's if you put a circle inside of a triangle or any other figure, see how this point T is outside? Well, that means this piece is equal to this piece. Since W is out here, then this piece is equal to this piece, and then this one is equal to this one. So technically, when I put the circle inside, I got 6 separate pieces. Now, since it is circumscribed about the circle, the perimeter is 50, so the perimeter of the triangle is 50, and what we're going to find is what these 2 pieces are here, so that I can find the whole side TR. So I want to know what this whole side is, but in order to get that whole side, I have to find out what this piece is. So they told me that TK was 3, so that means TL is also 3, because they're the tangent lines coming from the same point. If this piece is 9.5, then this piece is 9.5. So now all I need to do is add these 4 pieces together. So I get 3 plus 3 plus 9.5 plus 9.5. So 3 plus 3 is 6. 9.5 plus 9.5 is 19. So that would be 25. Okay. So now that I know that just this part of the triangle is 25, the whole triangle is 50. So 50 minus 25 gives me 25, which means I have to share it between these 2. So if I divide by 2, I get 12.5. So that means that this part is 12.5. So is this one, because they're equal, because they're coming from the same point. So now I can look at this whole side here, which is what I wanted anyway. So I look at that whole side, and 3 plus 12.5. So I add the 2 pieces together, and I get 15.5. So this is 15.5. All right. Now, using some of these theorems for tangent lines, since AB is tangent and AC is tangent, and they're both coming from the same point, AC is going to be equal to BA. AD is a secant because it goes through the circle at 2 places. And if you will notice, OD, OC, OE, and OB are all radius, so they're all the same. The radius is drawn to the point of tangency, so that's a right angle, and this is a right angle. So now all I got to do is just label everything. Well, OA is 12, so this whole thing is 12. Don't want to label it 12 because it'll be weird. OB is 6. So if OB is 6, OE is 6, OC is 6, OD is 6. Well, remember OA was 12? Well, if OE is 6, then EA is also 6, because the whole thing is 12. The measure of angle BAC, so this whole angle is 60. Well, if this side is equal to this side and this side is equal to this side, then that means this is a bisector. So this becomes 30 and 30, which makes this angle up here 60. So now we're going to find the following. So remember, this is a central angle, so this arc is also 60. This arc is also 60. All right, so now OC. OC is 6. ED. ED is the diameter, goes through here, so that would be 12. AB, oh, that's this side here. I haven't found that side yet. So let's look. I've got this triangle here where I've got, that's 12, that's 6, and I need that. So it's a 30, 60, 90. So remember the rules on 30, 60, 90. This side is x, the hypotenuse is 2x, and this side is x square root of 3. Well, since x is 6, then that just means that this side is 6 square root of 3, which means so is that one. So AB is 6 square root of 3, and so is AC. BAO, well, we already determined that it's 30. OCA, remember it's perpendicular, so it's 90. OAC, or AOC, sorry, AOC, so that's 60. EOC, it's the same angle, just using different letters. And then EA, which we found to be 6 because the radius was 6 also. All right, see you guys next time.